Tech by Tips.
Welcome to another Tech by Tips video. In today's video, we're going to continue our series here on creating a Kubernetes cluster with Raspberry Pis that are booting from the network, specifically using iSCSI, getting the most performance and the most close to native storage as possible that we can. And in the previous video, we set up our LUNs, and by doing that, we should be able to boot our Raspberry Pis from the network. And I already have a series of Raspberry Pis that I'm going to use for this Kubernetes cluster that are already booting from the network. So we can validate that by logging into the first of our Raspberry Pis here. I'm going to do a df-h, and we can see that the boot firmware is coming from an NFS share, and we have a dev SDA mounted that is 64 gigs, and that's from the iSCSI that we're using. We can validate that by looking at the fstab file, and you can see that it has the UUID that we specified here, and everything's looking good. Let's clear this out. The first thing I'm going to do here is I'm going to install Kubernetes in the first master node. I'm going to use two master nodes for this cluster. So what I'm going to do is I'm going to use Raspberry Pi 1 for this, and I'm going to use this command, which is the curl, to get this script from kubernetes.io, and then execute it with the shell, setting it as a server, making sure that the right kubeconfig mode is 644. We're using the snapshot native, and we're initializing a new cluster. And as we can see, it's going to be using version 129.3 for this cluster. And it downloaded everything that it needed, and it's setting everything up, and now it's starting Kubernetes. So it was a pretty fast process here to get this going. Now we should wait until it finishes, and then we're going to do a quick check to make sure that Kubernetes is running on this master node. Alright, so now if we go kubectl get nodes, we get that we have our master node here. It says it's the control plane master node. Perfect. Now we're going to add a secondary master, so I want another master. For that, I need to grab the token of this cluster from this master. So I'm going to run this command that says output the contents of var lib rancher kubernetes server node token. And I'm going to get this code that is a token, and I'm going to copy that because I need to use it later. So I'm going to save that into a notepad, and then I'm going to clear here. And basically this is what I have to do on this first node. So I'm going to exit out of here, and then I'm going to SSH into the secondary master, which is going to be this one, Pi 12. And as we can see, this is also running from the network, so everything is good here. And now I'm going to say, okay, install the Kubernetes system on this Pi, but let's make sure that you run this as a secondary master by using this token that you got from the primary master. So we're going to put that here. And then we have to specify the IP of the primary master. So in my case, 10.0.0.80. So it says run the script from kubernetes.io, use this token, and make sure that you run this to set up as a server, connecting to this other primary node, and make sure that you use mode 644 for the kubeconfig and the snapshotter active. So then we run this, and now we can see that it's doing the same thing. It's going to use the same version, 129.3, and it downloaded everything. It's setting up the whole system. It's starting Kubernetes. So let's wait a little bit for this to be done. And there it is, it's done. You can clear out of this, and let me just check again with the kubectl get nodes, and we see that now we have two nodes, and both nodes are master nodes. So we have Pi 1 and Pi 12 as our two master nodes. Everything's looking good so far. We can clear this, and now we can work on adding actual worker nodes. So in this case, I'm going to exit out of this Pi. Let's go then and get into another Raspberry Pi. Again, this is booting from the network, as we can see, dev SDA, and as we can see here, the boot firmware is from the network, and the UUID is pointing to the LUN that we're having in our network. Alright, we're going to run the following command, which is getting the script again, but then we're going to say point to the master node using the master node's token to set up this other Raspberry Pi as a working node. So we execute this, and then we see it's downloading version 129.3, and it's setting it up and enabling the Kubernetes agent. So we're seeing that this is an agent, this is going to be a worker node, and it's starting the Kubernetes agent. Everything's looking good right now. Let's wait for it to finish doing its work, then we can validate. We can validate here that if we try to do kubectl get nodes, we can't do that because this is not a master node. That kind of let us know. Now let's go back into the master node, and in here let's do that kubectl again. And now we see that we have a third node here that is not a master node, it's just a worker node that has been added to the cluster. So we can keep on doing this to all other machines that we want to join to this cluster. So now we have our 4 nodes. 2 of them are masters, 2 of them are workers, and that's basically the part of how do we get the Kubernetes cluster started. Now, another thing that I want to do in my case is I want to be able to do a DNS round robin so that whenever I connect to my cluster, I use it using a name for the cluster instead of specifying the master nodes names or IPs. So for that, what I'm going to do is I'm going to go into my router. I'm going to show you 2 examples of how to do this. For example, if you have Verizon files, which is what I do, you can go into your advanced settings and then to the DNS server, and in there you can create an entry here for the name that you want to give to that. So for example, let's say I want to use cluster and I want to use the IP of that master node, and then I apply that, and then in my case I had already created one for the first master node, which was cluster also. But then when we look at it, now we have 2 entries for cluster, one for the secondary master and the other one for the primary master here. So now whenever we go in Windows, for example, into a command prompt Windows, and when I do ns lookup and I say give me cluster, it's going to tell me I have 2 servers that are responding to the name cluster. So I'm doing round robin basically to the 2 master nodes of the Raspberry Pi cluster by doing this. If you were using, for example, a Raspberry Pi as your DNS server in your home, then it would have to be done in another way. For example, if I log into my Raspberry Pi, which serves as the DNS blocker and the resolution in my network, then I would go here where it says local DNS records, and then I can create one here that says cluster and then the IP that I want to associate with that. But we have a problem. In the Raspberry Pi user interface, you cannot add more entries that say the same name. So the workaround for this is, let's get rid of that. You would have to go into your Raspberry Pi, and then you go into the etc Pi-hole folder, and then you look for the custom list that is being used for DNS by this part here, which is this, etc Pi-hole custom list. And then in there you can manually put multiple entries with the same name, and then it'll show up here and it'll work. So let's do that real quickly. Since my Raspberry Pi is running from a Docker container, I can come here into the folder that I've mapped in the NAS, and then I go here in custom list, and then I can put here the entry for that. So it would look something like this. I save this, and then once I save it, I go back into my user interface here in the Pi-hole, and when I refresh, we can see that now we have 2 different entries for the same name in the network. So that's how you get over that restriction in the user interface. Just wanted you to know that. And then if this is your DNS resolution for your local network, it'll be able to point at any of those 2 Raspberry Pis whenever you try to reach cluster. Now I want to retrieve the kubeconfig file from the master node. So what I'm going to do is I'm going to run this command here. I'm going to paste it here, and what this is going to do is it's going to get the, let me just show it first, the contents of this file here, which is the kubeconfig basically for this cluster, and it's going to dump it into a file in the home/.kube folder. That's going to be our kubeconfig. So now if we go, let's clear this out. If we go into here and we say show me what I have, so now we have that file stored in there, and we can then use it to connect to the cluster. We can extract that out of the Pi and use something like Lens, for example, to have a good visualization of our cluster from our desktop computer, stuff like that. So now we have that accessible. Now another thing we want to do is I want to make sure that this actually responds whenever I say cluster in my network, instead of having to run this kubeconfig locally here in the Pi. So I need to change this IP address to the name that I have assigned in the network for both master nodes. So I'm going to do that with this command that I'm going to execute. This command here, which basically says you set to replace 127.0.0.1 with the word cluster in that file, which is our kubeconfig. So when I run that and I show that again, we see that it's going to be listening on HTTPS cluster and then that port instead of localhost. So now this kubeconfig is usable for us to access this cluster in our local network. So now what I'm going to do is I'm going to copy this kubeconfig file here, all of its contents, and I'm going to drop it into a new notepad, and I'm going to save this as in the desktop as the cluster config, and that's saved there. So now if I open an application like Lens, I should be able to use that kubeconfig file to manage my Kubernetes Raspberry Pi cluster from my computer instead of having to be inside the Raspberry Pi master to access it. So this is all for this video. We have now a working Kubernetes cluster running on Raspberry Pis that are booting from the network using iSCSI, and everything is running smoothly. If you like the content, like and subscribe to the channel. It'll help us a lot. Share the videos with people if you think they find it useful, and also feel free to leave comments in the comment section below with things that you would like to see, and any other discussion is highly encouraged. And this is going to be it for this one. Thank you very much. I'll see you in the next one.